Okay, so now you've seen two of the big ideas of networking. The first is that the network is built out of a bunch of layers. And the second is that the network sends messages as individual packets with headers. So now we're going to see what happens when you take these two big ideas of networking and put them together. And to do that, we're going to walk through an example with the post office again. Okay, so suppose we have two CEOs, Alice and Bob, and Alice wants to send a message to Bob. So what might this look like in our analogy? Well, the first thing is Alice is going to read out her message, and Alice's secretary is going to type down this message. At the top of the letter that Alice's secretary is typing, the secretary might add a header that says, "This is meant for Bob," and then print out this letter. And the next thing that happens is, once Alice's secretary has this letter printed out, the secretary is going to put it in an envelope. On the envelope, it's going to have Bob's company's address, and then the secretary is going to give this sealed envelope to the mailman. And now the mailman is going to look at the envelope, see that it has Bob's company's address on it, and send the message over to Bob's company's address. So now that the message has reached Bob's building, the secretary can open up the envelope, look at the top of the letter, and see that it says, "This is for Bob." And so the secretary is going to read the message to Bob, and now Bob has the message. Okay, so what did we learn from this whole analogy? Well, we saw this idea of layers because Alice and Bob are the top layer, and then the secretaries are a lower layer, and then the mailman are the lowest layer. And we also saw this idea of packets and headers because when Alice reads out her message at first, it's a plain message, and then the secretary adds a secretary header that says, "This is for Bob," and then the mailman adds a header by putting it in an envelope. And then on the other side, the envelope comes off first, and then the secretary looks at the header, sees this is for Bob, and then Bob gets the original message back. So what we saw is that as you move down in the layers, so as you move from higher layers to lower layers, we keep adding more and more headers, and they keep being wrapped around on the outside. And then on the other side, as we move back up the layers, from the lower layers all the way back up to the higher layers, we're peeling off the headers one by one. So this idea is as you move down the stack and as you move to lower layers, you add on more headers. And then on the other side, as you move up the stack and you go to higher layers, you remove the headers one by one. So this is kind of how the headers and the idea of layers work together. So you're going to have multiple headers. And so now we're going to hand it over to Dave again, and he's going to show you this idea of how headers and layers kind of work together and how every packet is going to have multiple headers.
We draw layering diagrams like this, where the idea is the lower layers are providing more basic services, and each layer uses services provided by the layer below it. And just a little bit of a caveat, I'm going to draw the lower level layers down on the bottom of these pictures. The more basic ones go on the bottom of these pictures. But then when we draw packets, the structure of a packet format is going to be influenced by this decomposition of the code, by the layering. So the headers are actually going to be broken down into sort of a piece of the header for each layer. And then just a warning that we're used to writing packets left to right or top to bottom, and it's going to turn out that they're actually going to be in the reverse. It's going to be like upside down. The lowest layer is going to have the leftmost, the first beginning part of the packet header. So it might be at the top or it might be at the left. And just as a joke, people like to talk about a hypothetical layer 8 that's like people or politics or economics or something like that. You are very welcome to interrupt. I'm going to start diving into some packet formats. Okay, here we go. Yeah, a packet. Okay, so I mentioned that there's multiple layers. And the way that's going to show up in the format of the data is that our packet is actually going to have multiple of these headers. So there's going to be some application data, that what we think of as the contents, the message that the application is trying to send. And there's going to be multiple protocols, multiple layers that are involved in sending that. So there might be a link layer header. That would be like an Ethernet header that's indicating for while this packet lives on one local area network, what's the source and the destination machine on that Ethernet network. And there's an IP header that's saying this packet is eventually going to go to some machine on the internet. So, what's the eventual destination of that? And there might be a transport layer header, something like TCP. We'll talk about each of these, that is responsible for dealing with if the packet gets dropped, making sure that it's resent so no data is lost. So this layering in this code is going to show up in the packet format. And the standard way that this layering works is that you have the headers in the series from the lowest layer onward. Okay? So from the perspective of the Ethernet network, the way to think about how this looks from the Ethernet network is the Ethernet network thinks there's an Ethernet header here followed by some stuff. And the Ethernet machines, the Ethernet code, can ignore everything after this. So from the perspective of the Ethernet network, this is the header, and everything after here is the payload from the Ethernet viewpoint. Okay, like the way your Ethernet card works. It's not trying to interpret anything after the link layer header. So the Ethernet card can look at that link layer header. The Ethernet device driver can look at that link layer header, figure out, is this packet for me or not? And if so, remove the header, and then pass on the rest up to the code that's responsible for interpreting the IP, the Internet Protocol. Then that code, your networking code that does the Internet Protocol is going to be thinking, well, here's the only header that matters to me. It's the IP header. And everything after that, it's just considering as payload. It's considering as arbitrary data. It's not trying to interpret. It's ignoring. Okay, so for each layer in the code, it's only looking at its own header, and it thinks of everything else after that as opaque and irrelevant, and it's not going to try to look at it. It's just going to copy that onward. Okay, so this structuring gives us some way to separate out the concerns, so each layer only has to deal with certain subset of the concerns you might eventually have. I saw a question. All right, so that's what a packet might look like if I draw it horizontally, or I might draw it vertically. And I warned you that the lower layers are going to have headers that are at the top if we draw it vertically. So just beware.